I'm sure you've heard that one way of achieving success is to set goals. For each section, we have listed the goals you can expect to master by completing that section. The format of each section will be as follows: a review of the goals for the section, followed by the lecture, which contains clear explanations and many examples. Next, there will be a problem-solving session, where I'll walk you through the resolution of additional sample problems. Finally, there will be a section of more difficult problems to further illustrate the topic. These have an asterisk by them in the workbook. When you finish this section, you should be able to 1. Recognize positive and negative numbers. Number 2. Draw and define a number line. 3. Recognize and use greater than and less than symbols. 4. Draw a simple graph. Number 5. Graph a point on a number line. 6. Define and take the absolute value of a number. Algebra is a branch of mathematics that uses symbols to represent numbers according to the rules of arithmetic. Let's begin our study by looking at positive numbers. Positive numbers are greater than 0 and are represented as follows. Up until this point, you have probably only associated the plus sign with addition. However, a plus sign preceding the number makes it positive. No sign preceding the number makes it positive. Let's look at some example problems. Using the plus sign to represent a positive number, you have positive 75, positive 101, positive 10,500. Using no sign to represent a positive number, you have 75, 101, 10,500. As you might suspect, positive numbers have a counterpart, an opposite if you will. If positive numbers represent gain, the negative numbers represent a loss. Let's look at the definition of a negative number. Negative numbers are numbers which are less than 0 and can be represented as follows: a minus sign preceding the number. Note the following examples: negative 10, negative 37, negative 107. There is one number, however, that we have not mentioned thus far. That is because it does not fall into either category. Have you already guessed which number I'm referring to? 0 is neither positive nor negative. 0 can be thought of as a divider between positive and negative numbers. Negative numbers are on the left side of 0. Positive numbers are on the right side of 0. Thus, one cannot represent 0 by placing a plus sign or a negative sign in front of it. There are many types of numbers in arithmetic, and most, if not all, will be included in your study of algebra. Let's look at a definition of a natural number and a few examples. Natural numbers are positive counting numbers. 1, 2, 3, 4, 5 are valid examples of natural numbers. The 3 dots that follow the 5 mean that natural numbers are infinite. Infinite means that it continues without end. Already, you've been exposed to 3 types of numbers: positive, negative, and natural numbers. Now that you have this information, you might be wondering, what can you use it for? What you've learned thus far will assist you in creating a simple number line. Let's look at the next concept that will help you accomplish this feat. A directed line segment is denoted by a line with an arrow on the end. When you join a straight line and an arrowhead, you form a directed line segment. A number line is a directed line segment that can represent various types of numbers. Remember that if the numbers are removed from a number line, it is only a directed line segment. The above example represents a positive number line. Note that positive number lines point to the right or up. Have you noticed that some of the numbers we've covered thus far seem to overlap? For example, positive and natural numbers have some of the same characteristics. Let's look at another number that possesses similar properties. Integers are negative and positive whole numbers, including 0. -2, 1, 0, 7 are examples of integers, while 3/4, 1.5, -1.2, 2 and 3/4 are not integers. Notice some of the properties of integers on a number line. Positive integers are located to the right of 0 on the number line. All of these numbers are greater than 0 and represent a gain. In the above number line, 1, 2, 3 are positive integers. Negative integers are located to the left of 0 on the number line. All of these numbers are less than 0 and represent a loss. In the number line above, -2 and -1 are negative numbers. There is one interesting property that we haven't observed with respect to negative numbers. Have you noticed that the further the number goes to the left of 0, the smaller its value? Thus, -27 is less than -1. -1000 is less than -5. There is a simpler way to express this statement by using symbols instead of words. There are 6 equality relations. We are only going to use 2 at this time. When the arrowhead opens to the left, it means greater than. The following example is read as 1 is greater than -5. When the symbol opens to the right, it means less than. It is read as -5 is less than -1. A graph is a visual representation of a collection of points that satisfy a given relation. Don't worry if you don't understand this definition. It will be explained in greater detail later. To graph a point on a number line, one has only to put a dot over the number on the number line. For example, to graph the number 1 on the number line, simply place a dot over the number 1 on the number line. The last concept we're going to discuss before working some additional example problems is absolute value. Absolute value is denoted as the positive distance from 0. It is never a negative number. Its value is either positive or 0. The symbol 2 vertical lines is used to represent the absolute value of a number. The number 5 between the 2 vertical lines is read as the absolute value of 5. The number -3 between the 2 vertical lines is read as the absolute value of -3 equals 3. You cannot have negative distance. Think of going on the journey as positive and returning as negative. Although the direction is negative, the distance is not. With absolute value, always use 0 as the starting point. Compute the absolute value by counting the point's distance from 0. but do not include 0 as part of this distance. Thus, the absolute value of 3 is computed as follows. From 0 to 1 represents one interval. There are a total of 3 intervals from 0 to 3. If the concept of absolute value still seems a little vague, the graph of the following problems should resolve that situation. Recall the definition of absolute value, the positive distance from 0. To take the absolute value of negative 3, count the number of intervals from 0 to negative 3. To take the absolute value of positive 3, count the number of intervals from 0 to positive 3. Note that the number of intervals from 0 to negative 3 and 0 to positive 3 is the same. The only noticeable difference is that in one instance you counted towards the left and the other you counted towards the right. Absolute value is concerned with distance and not direction. You have seen the first two cases of absolute value, but the third is new to you. However, it is not a difficult concept to understand when looked at with the proper perspective. You have already learned that the absolute value of negative 27 is 27. In the above example, by placing the negative sign outside of the absolute value symbol, it is unaffected by the operation. Therefore, the minus sign outside of the absolute value symbol yields the negative result. Points to remember. Number 1, positive numbers lie to the right side of 0. Number 2, negative numbers lie to the left side of 0. Number 3, a number line is a directed line segment with numbers placed at regular intervals on it. Number 4, greater than and less than symbols define a relationship between numbers on a number line. Number 5, absolute value is defined as the positive distance from 0.